Hello and welcome to the first part of 3 for the high school chemistry. So what is chemistry? So according to the ACS, chemistry is a study of matter defined as anything that has mass and can take up space, and the changes that matter can undergo when it is subject to different environments and conditions. Chemistry seeks to understand not only the properties of matter, like the mass and composition of a chemical element, but also how and why matter undergoes certain changes, whether something transformed because it combined with another substance, froze because it was left for 2 weeks in a freezer, or changed colors because it was exposed to too much sunlight. So in chemistry, a periodic table is used in many chemistry classes. A periodic table of the chemical elements arranged in order of atomic number, usually in rows, so that elements with similar atomic structure and similar chemical properties appear in vertical columns. So the next slide, we have an example of a periodic table. And for each of the elements that it shows on the right of the screen, you can see there's an example of mercury. So in that, each of the boxes for each element includes the element name, so that's mercury in this case, and the atomic number, 80. So in the periodic table, the atomic number increases from left to right. And then once you're at the rightmost row, it moves down. And it starts with 3, 4, and 5, 6, 7, 8, and so on. And then the symbol, which is for mercury, Hg. So the symbol is just like a short 1 or 2 letter symbol that represents that element. So like hydrogen would just be H, and phosphorus would just be a P. And the next below the symbol is the average mass. This is the atomic mass of the element. And that is how many grams of that element can be found in 1 mole, which is what we'll get into in the next video. And below that is the electronegativity, which is one of the periodic trends that we will also cover later in this video. So this periodic table is color-coded to help show how it is organized. So there are multiple different groups of elements. So if you look at the white, the non-colored, these are all non-metals. And then you look at the leftmost side, and the light blue, where it starts with Li and then goes down into francium, which is Fr. And that is the alkali metals that only composes of 6 of the elements. And right next to that is the dark blue side, which starts with Be and then ends with Ra. And that is the alkaline earth metals. And then the dark green, so like the middle section that is colored, starting with Sc and ending with Lv, and also includes aluminum. This is the transition metals. And these metals, most of them don't have a set charge. So they'll usually be bonded to alkali metal or an alkaline earth metal. And so if the charge of, let's say, nickel is 2 plus, so it would be labeled as Ni and then in parentheses 2 in Roman numerals. Then you would need Na2 Ni because Na has a charge of 1 plus. So we'll get into this in the later videos. And then the yellow, which starts with B and At, it is the metalloid section, which is also non-metal. And then this one that starts with francium here towards your right side and ends with iodine is the halogens, which are also non-metal. And the far right side, which starts with helium and ends with Rn, this is the noble gases, which are also non-metals. And on the bottom, you have the starting with Lu actually, if you look at the near the transition metal side, and starting with and ending with Yb, which is on the bottom, you have the lanthanides. And then you also have the red bottom section, which starts with Lr, which is also near the transition metals, and ends with No. This is the actinides. I do not know if I'm saying that correctly, but I think that's how you pronounce it. And then, so in the periodic table, you have a period number and a group, or also called a family number. So the periods are labeled 1 through 7 right here, which is the horizontal rows. And then the families or the groups are the vertical rows, which are labeled 1 through 18. So periodic trends. So there are multiple trends on the periodic table. So these would just be like an example, atomic radius for francium would be the highest because it increases this way. We'll get into that after I explain the definition. So atomic radius is the half the distance between the two atoms. And the atomic radius, as you can see in this, increases, well, the atomic radius decreases as you go from left to right across a period, which is left to right from the bottom. As you can see, it goes from, well, in this case, it shows it increasing from right to left. So it's increasing from right to left. And this is because there are stronger attractive forces in atoms as you go from left to right on the periodic table between the opposite charges in the nucleus and electron cloud, because of the atom can be sucked together a little tighter. This is also called Coulombic attraction. And the atomic radius increases as you go down a group. So it increases from top to bottom. And this is because there's a significant jump in the number of nucleus. So like in a nucleus, that includes a proton and neutron. Each time you move down from a period. Additionally, new energy levels of electron clouds are added to the atom as you move from a period to a period below down a group, making each atom significantly more massive, both in size and volume. And then the next one is ionization energy, which is the amount of energy required to remove the outmost electron. And this is really similar to electronegativity. And they have the same atomic, periodic trend. So for ionization energy, it increases as you go from left to right across a periodic table. And this is because elements on the right of the chart want to take others' atoms' electrons. And this is because they are close to achieving the octet, which is 8 electrons around them. This means that it will require more energy to remove the outermost electron. Elements on the left of the chart would prefer to give up their electrons, so it would be easy to remove them, requiring less energy. So that would make it a lower ionization energy. And ionization energy decreases as you go down a group. Why? Because a shielding effect makes it easier to remove the outermost electrons from those atoms that may have many electrons, which is those that are in the bottom of the chart. And then the next periodic trend is electronegativity, which is an atom's desire to grab another atom's electrons. And this, another important key to this is when an atom is bonded to another atom. So then electronegativity increases as you go from left to right. So this periodic trend is similar to the ionization energy. So it increases as you go from left to right. And this is because the elements on the left of the periodic table have 1 to 2 valence electrons and would rather give those few valence electrons away to achieve the octet in a lower energy level. So they would rather do that than grab another atom's electron. So if you look at the periodic table, the most left side, these have 1 to 2 valence electrons. And if they give them up, let's say sodium, the Na, if it gives up 1 valence electron, it'll move away. It'll basically achieve an octet, and it will move to the Ne. That'll become neon, because that's how it wants to reach its octet. So as a result, they have a low electronegativity. Elements on the right side of the periodic table only need a few more electrons to complete the octet. So they have a strong desire to grab another atom's electrons. So if you look over here, chlorine, Cl, it's only one valence electron away. So it has 7. So it just needs one more to reach argon, which is an octet. So all the noble gases have already reached octet. They have 8 valence electrons. Chlorine here has 7. So it needs one more to reach octet, which is 8 valence electrons. And electronegativity decreases as you go down a group. This is because elements near the top of the periodic table have few electrons to begin with. Each electron is a big deal. They have a stronger desire to acquire more electrons. Elements near the bottom of the chart have so many electrons that losing or acquiring an electron is not as big a deal. This is due to the shielding effect, where electrons in lower energy levels shield the positive charge of the nucleus from outer electrons, resulting in those outer electrons not being as tightly bounded to an atom. So that is the periodic trends. There are many other trends, but these 3 are usually the main trends that are talked about. There's also metallic character, and that increases, as you can see here in the middle of the periodic table, it increases towards the left bottom, and it's non-metallic is towards the right top. So another big part of chemistry is lab, and lab safety is very important. So for equipment, there's usually a fire blanket and a fire extinguisher. A fire blanket should be used to smother flames. A fire extinguisher is to be used to sweep across the bottom of a flame. And this is important not to spray it on people. Fume hoods are also in chemistry labs, and they have chemicals that are not as safe as others. So you do not want to remove these chemicals or experiments from the hood. And there's usually a glass container where you would place all of your broken glass. An eye wash station you would use to wash your eye in case it had any chemicals go into it. However, you should have worn goggles at all times during the experiment. And in case you get chemicals spilled all over you, there should be a shower, which you can pull the handle to turn on. And you should also wash your hands after every lab, because chemicals can get on your hands and some can be very bad for your skin. And chemicals do not come off with hand sanitizer, so it is very important to wash them with soap. The big rules during a lab is no eating, drinking, or chewing gum. And also, if a spill occurs, you should notify a teacher. And during a lab, or any time in a lab, you should never perform unauthorized activities. And you should always be wearing closed shoes and not be barefoot. Wear goggles is a main thing. It's a really big thing not to get chemicals in your eye, and no horseplay. So you should be listening to the teacher and paying attention to the lab and completing the lab. And after the lab is done, you should clean up your equipment that you used and your lab station to get ready for either the next class or whatever is going on next, and not to keep any chemicals on the counter where you did your experiment spilled. So if something spills, you should notify your teacher and block the area, and also follow your teacher's instructions. And when you cut yourself on broken glass, you should notify the teacher and move away from the broken glass to make sure you don't get hurt again. If chemicals do spill on your skin, you should notify your teacher and wash hands with water or soap. Water and soap, not or. You got to do both. And then if it is a spill in a majority of your body, you should most likely be using a shower. So just make sure you listen to your teacher. So the next video, part 2 of 3, we will go over protons, neutrons, and electrons. And we will also go over net charge and how to do a complete atomic designation, which will require a little bit of math. Thank you.